Welcome. Polytetrafluoroethylene (PTFE) is a synthetic fluoropolymer of tetrafluoroethylene that has numerous applications. The best-known brand name of PTFE-based formulas is Teflon by Chemours. 2. Chemours is a 2015 spin-off of DuPont Co. 3, which discovered the compound in 1938. 2. PTFE is a fluorocarbon solid, as it is a high molecular weight compound consisting wholly of carbon and fluorine. PTFE is hydrophobic, neither water nor water-containing substances. What PTFE is fluorocarbons demonstrate mitigated London dispersion forces due to the high electronegativity of fluorine. PTFE has one of the lowest coefficients of friction of any solid. PTFE is used as a non-stick coating for pans and other cookware. It is non-reactive partly because of the strength of carbon-fluorine bonds, and so it is often used in containers and pipework for reactive and corrosive chemicals. Where used as a lubricant, PTFE reduces friction, wear and energy consumption of machinery. It is commonly used as a graft material in surgical interventions. Also, it is frequently employed as coating on catheters. This interferes with the ability of bacteria and other infectious agents to adhere to catheters and cause hospital-acquired infections. PTFE was accidentally discovered in 1938 by Roy Plunkett while he was working in New Jersey for DuPont. As Plunkett attempted to make a new chlorofluorocarbon refrigerant, the tetrafluoroethylene gas in its pressure bottle stopped flowing before the bottle's weight had dropped to the point signaling empty. Since Plunkett was measuring the amount of gas used by weighing the bottle, he became curious as to the source of the weight, and finally resorted to sawing the bottle apart. He found the bottle's interior coated with a waxy white material that was oddly slippery. Analysis showed that it was polymerized perfluoroethylene, with the iron from the inside of the container having acted as a catalyst at high pressure. Kinetic Chemicals patented the new fluorinated plastic, analogous to the already known polyethylene, in 1941-4, and registered the Teflon trademark in 1945. 5-6. By 1948, DuPont, which founded Kinetic Chemicals in partnership with General Motors, was producing over 2 million pounds (900 tons) of Teflon brand PTFE per year in Parkersburg, West Virginia. 7. An early use was in the Manhattan Project as a material to coat valves and seals in the pipes holding highly reactive uranium hexafluoride at the vast K-25 uranium enrichment plant in Oak Ridge, Tennessee. 8. In 1954, the wife of French engineer Marc Grégoire urged him to try the material he had been using on fishing tackle on her cooking pans. He subsequently created the first Teflon-coated, non-stick pans under the brand name Tefal, combining TEF from Teflon and Al from aluminum. 9. In the United States, Marion A. Trizzolo, who had been using the substance on scientific utensils, marketed the first U.S.-made Teflon-coated pan, the Happy Pan, in 1961. 10. However, Tefal was not the only company to utilize PTFE in non-stick cookware coatings. In subsequent years, many cookware manufacturers developed proprietary PTFE-based formulas, including Swiss Diamond International, which uses a diamond-reinforced PTFE formula, 11, Scanpan, which uses a titanium-reinforced PTFE formula, 12, and both All-Clad, 13, and Newell Rubbermaid's Calphalon, which use a non-reinforced PTFE-based nonstick. 14. Other cookware companies, such as Meyer Corporation's Anilon, use Teflon. 15. Non-stick coatings purchased from DuPont. In the 1990s, it was found that PTFE could be radiation cross-linked above its melting point in an oxygen-free environment. 16. Electron beam processing is one example of radiation processing. Cross-linked PTFE has improved high-temperature mechanical properties and radiation stability. This was significant because, for many years, irradiation at ambient conditions has been used to break down PTFE for recycling. 17. This radiation-induced chain scission allows it to be more easily reground and reused. PTFE is produced by free radical polymerization of tetrafluoroethylene. The net equation is NF2C equals CF2 minus F2C minus CF2 N minus. Because tetrafluoroethylene can explosively decompose to tetrafluoromethane and carbon, special apparatus is required for the polymerization to prevent hot spots that might initiate this dangerous side reaction. The process is typically initiated with persulfate, which homolyzes to generate sulfate radicals. O3SO-OSO3 2-2SO4-. PTFE is a thermoplastic polymer, which is a white solid at room temperature, with a density of about 2,200 kg per cubic meter. According to Chemours, its melting point is 600 K, 327 degrees Celsius, 620 degrees Fahrenheit. 19. It maintains high strength, toughness and self-lubrication at low temperatures down to 5 K, minus 268.15 degrees Celsius, minus 450.67 degrees Fahrenheit, and good flexibility at temperatures above 194 K, minus 79 degrees Celsius, minus 110 degrees Fahrenheit. PTFE gains its properties from the aggregate effect of carbon-fluorine bonds, as do all fluorocarbons. The only chemicals known to affect these carbon-fluorine bonds are highly reactive metals like the alkali metals, and at higher temperatures also such metals as aluminum and magnesium, and fluorinating agents such as xenon difluoride and cobalt-3 fluoride. Image for Teflon tape. The coefficient of friction of plastics is usually measured against polished steel. 27. PTFE's coefficient of friction is 0.05 to 0.10. 19, which is the third lowest of any known solid material, bambing the first, with a coefficient of friction of 0.02, diamond-like carbon being second lowest at 0.05. PTFE's resistance to van der Waals forces means that it is the only known surface to which a gecko cannot stick. 28. In fact, PTFE can be used to prevent insects climbing up surfaces painted with the material. PTFE is so slippery that insects cannot get a grip and tend to fall off. For example, PTFE is used to prevent ants climbing out of formicaria. Because of its chemical inertness, PTFE cannot be cross-linked like an elastomer. Therefore, it has no memory, and is subject to creep. Because of its superior chemical and thermal properties, PTFE is often used as a gasket material within industries that require resistance to aggressive chemicals such as pharmaceuticals or chemical processing. 29. However, because of the propensity to creep, the long-term performance of such seals is worse than for elastomers which exhibit zero, or near zero, levels of creep. In critical applications, bevel washers are often used to apply continuous force to PTFE gaskets, ensuring a minimal loss of performance over the lifetime of the gasket. 30. Processing PTFE can be difficult and expensive because the high melting temperature 327 degrees Celsius, 621 degrees Fahrenheit, is above the initial decomposition temperature 200 degrees Celsius, 392 degrees Fahrenheit. 31. Even when melted, PTFE does not flow, but instead behaves as a gel due to the absence of crystalline phase 32, and high melt viscosity. 33. Some PTFE parts are made by cold molding, a form of compression molding. 34. Here, fine powdered PTFE is forced into a mold under high pressure 10 approximately 100 megapascals. 34. After a settling period, lasting from minutes to days, the mold is heated at 360 to 380 degrees Celsius, 680 to 716 degrees Fahrenheit. 34, allowing the fine particles to fuse into a single mass. 35. The major application of PTFE, consuming about 50% of production, is for wiring in aerospace and computer applications, e.g. hookup wire, coaxial cables. This application exploits the fact that PTFE has excellent dielectric properties, 36, especially at high radio frequencies, 36, making it suitable for use as an excellent insulator in connector assemblies and cables, and in printed circuit boards used at microwave frequencies. Combined with its high melting temperature, this makes it the material of choice as a high-performance substitute for the weaker and lower melting point polyethylene commonly used in low-cost applications. In industrial applications, owing to its low friction, PTFE is used for plain bearings, gears, slide plates, and more applications with sliding action of parts, where it outperforms acetal and nylon. 37. Its extremely high bulk resistivity makes it an ideal material for fabricating long-life electrets, the electrostatic analogues of magnets. 36. PTFE tapes with pressure-sensitive adhesive backing. Pyrolysis of PTFE is detectable at 200 degrees Celsius (392 degrees Fahrenheit), and it evolves several fluorocarbon gases and a sublimate. An animal study